Hello everyone. So today we're going to go over section 6.0b, adding and subtracting fractions. So last time we looked at adding and subtracting proper fractions and the need for common denominators. Today we'll be adding and subtracting improper fraction as well as mixed numbers. So first, in example 1, we are going to rewrite each improper fraction as mixed numbers. In the first case, we have 7 over 4. So if we divide 7 by 4, we'll get 1 and a remainder of 3. So 7 over 4 as a mixed number will be 1 and 3/4. Likewise, in example B, 25 divided by 9 will give us 2 and a remainder of 7 over 9. In the third case, we have 16 over 5. So 16 divided by 5 gives us 3 and a 1 as a remainder. So we have 3 and 1/5. And in the last example, 24 divided by 7, that will give us 3 and 3/7. Okay, so adding improper fractions and mixed numbers, there are basically two things we can do. We can either change all the mixed numbers to improper fractions and then add or subtract, or we can change all the improper fractions to mixed numbers and then do the same. So usually questions, however, are given with mixed numbers, so let's try method 1 first. So in this case, we're going to change both 3 over 5 and 2 and 1/3. Well, actually, 3 over 5 is already a proper fraction. 2 and 1/3, however, is a mixed number. We'll rewrite it as an improper fraction. So in this case, we have then 3 over 5 and 2 and 1/3 as an improper fraction. We simply take 2 times 3, which is 6, plus 1, which is 7. So we have 7 over 3. Next, we are looking for the common denominator, so we can multiply by 3's in the first fraction, and multiply by 5 to both the numerator and denominator of the second fraction. So after we've done that, we are going to end up with 9 over 15 as our first fraction, and 35 over 15 as the second fraction. Now we can simply add the numerators together. So 9 plus 35, of course, is 44. And then now the final step, we are going to rewrite 44 over 15 as a mixed number. So 44 divided by 15 is equal to 2, with a remainder of 14 and then over 15. Okay, so that's the first example. Second one, similar kind of thing. So the first fraction we will rewrite as 2 times 6 is 12. 12 plus 1 is 13 over 6. Second fraction, 3 times 3 is 9. 9 plus 2 is 11. So this is 11 over 3. In this case, the lowest common denominator is 6. So we're going to multiply the second fraction by 2 in both the numerator and denominator, which will give us 13 over 6 plus 22 over 6. So now we can just add the numerators together, which gives us 35 over 6. And finally, we can rewrite the final answer as a mixed number. 35 divided by 6 gives us 5 and a remainder of 5 over 6. Okay. One more example here in example C. Once again, we start by rewriting both mixed numbers as improper fraction. The first one, 4 times 3 is 12. 12 plus 1 is 13. So this will be 13 over 3. And then we will subtract. 2 times 4 is 8. 8 plus 3 is 11. So this is 11 over 4. So in this case, the lowest common denominator is going to be 12. So we'll need to multiply both the numerator and denominator in both fractions. And in this case, we're going to end up with 52 over 12 minus 33 over 12. And if we take the difference here, 52 minus 33 gives us 19 over 12. And we'll need to rewrite this as, once again, a mixed number, 1 and 7 over 12. So the question now is, what is a disadvantage of this method? Well, if we change all the mixed numbers to improper fraction first, then we will have to change it back to mixed number at the end, which feels like an extra step, but sometimes is quite necessary. Okay, so what if we didn't change mixed numbers into improper fractions? What if we just left them the way they are? And then just try to add or subtract. Okay, let's see what happens. Well, in the first case, the lowest common denominator is 8, so we will be multiplying the second fractions, the 1/2 part, by 4 in both the numerator and denominator. So that will give us 4 and 5 over 8 minus 2 and 4 over 8. So we can subtract the whole number parts. 4 minus 2 is just 2. And the fraction parts, 5 over 8 minus 4 over 8 is 1 over 8. So that's it. So we didn't need to change this to improper fractions and then back into mixed numbers. So this is a bit faster. So let's look at a second example and see what happens here. So in this case, the lowest common denominator is 6. So go ahead and rewrite the second fraction. So we have 2 and 5 over 6 as the first fraction, and the second fraction is going to be 3 and 4 over 6. So notice what happens if we add here. So we add the whole number parts first. 2 plus 3 is 5. And the fraction parts added together gives us 9 over 6. Notice that 9 over 6 is an improper fraction. It's also reducible, so let's do that first. So we can divide both the 9 and the 6 by 3, which means the answer is equal to 5 and 3 over 2. However, 3 over 2, of course, still has the same problem of being an improper fraction. So now we need to rewrite just this part, the 3 over 2, which we know is equal to 1 and a half. So now we're going to need to correct that, and we get 6 and 1/2, right? Since mixed number really shouldn't contain in it improper fractions. All right, so that's one of the things that can happen if we don't first change the mixed numbers to improper fraction and just add it. We can end up with something that's kind of like an improper mixed number. Okay, let's look at the last example here. Okay, in this case, the lowest common denominator is going to be 18, so multiply each fraction accordingly. So the first fraction then becomes 5 and 3/18, while the second fraction becomes 2 and 10 over 18. Okay, notice that we could subtract the whole number parts. 5 minus 2 is just 3. However, if we subtract 3 and 10 from 3, we get -7, which doesn't really work. So what we can do is we can borrow 1 from the 5, and that is to say we can rewrite this as 4, and then 18 plus 3 is 21 over 18. Again, we have that kind of improper mixed number in there. But now notice we can actually subtract the whole number part. 4 minus 2 is 2. We can also subtract the fraction parts. 21 minus 10 is 11. So we have 11 over 18 for the fraction parts. So we can see some of the disadvantages when it comes to subtracting or adding just mixed numbers without changing them to improper fractions first. So in example B, we had a sort of improper mixed number that needs to be addressed. And that was in example B. In example C, we needed to borrow 1. Right? Whereas if we change all mixed numbers to improper fractions and then add or subtract it afterwards, we wouldn't run into also the problems from examples B and C. Okay, so now let's look at a couple more examples here. Adding, subtracting. Oh, the first question doesn't have a fraction part with the 5. The 5 is just a whole number, so we just have 5 plus 3 and then 1 over 20. So 5 plus 3, of course, is 8. And then the fraction part is just going to be 1 over 20. So that one's very straightforward. Second one is a little bit more complex. First thing we need to think about is what is the common denominator. In this case, we can multiply both the numerator and denominator here by 5 to give us a denominator of 20, which means if we multiply the second fraction by 2 over 2, we get a common denominator that way. So that will give us 10 and 5 over 20 minus 5 and 14 over 20, which means once again we need to borrow 1 from the 10. So this would be 9 and 25 over 20 minus 5 and 14 over 20. Right, and the way that this works, in case I wasn't being very clear earlier, is the fact that we can rewrite 1 in any case as 20 over 20. So if we borrow 1 from 10, we can rewrite it as 20 over 20 and add it to 5 over 20, and that's how we get to 25 over 20. Okay, so now that we have whole numbers and fractions we can subtract, we go ahead and do that. So 9 minus 5, of course, is 4. And 25 minus 14 is 11. And this is out of 20. So today we looked at adding and subtracting improper fractions and mixed numbers. And that's it for today. So thank you for listening.